So we're given this problem where we have two parents, okay? This parent on the left, this parent on the right. And we have to determine the number of phenotypes in the offspring and the number of genotypes in the offspring. So we start by making a Punnett square for each letter. So I took this AA from this parent and then this AA from that parent. And I did a Punnett square. So I come up with 1/4 big A, a 2/4 big A, little a, and a 1/4 little a. Same with this Punnett square. And this BB comes from this BB, or this parent. And this big B, little b comes from this parent. Combine them, get 1/4 big B, 2/4 big B, little b, and a 1/4 little b. Same with the next letter, C. So this little c comes from this parent, and this big C, little c comes from this parent. Combining them, we get 1/2 big C, little c, and another 1/2 big C, little c. Then we go to the next one, right here, D. So this big D comes from this parent on the left, and this little d comes from this parent on the right. Okay, combining them, we get 4/4 big D, little d, or just one big D, little d. And then this big E, little e comes from this left parent, and this big E comes from this right parent up here. Combining them, we get 1/2 big E, and then 1/2 big E, little e. And the number of phenotypes. So all we're doing is looking at each pattern, pretty much, from combining, doing the Punnett squares for each letter. So for the phenotypes, we know big A, dominant, so that's one phenotype. Big A, little that's still dominant, so that's just one phenotype. Little a, that's a different phenotype. These two are the same because A is dominant. So therefore there's two phenotypes for A times, we go on to B. Same with this one. So we have big B, that's one phenotype. But big B, little b is the same phenotype as big B. So this is 1, but little b is a recessive, homozygous recessive. So therefore it's a different phenotype. So this is 1, 2. Same for C. So we have, right here, we have 1/2 big C, little c, and then 1/2 little c. Big C, little c is one phenotype. C is dominant. Little c is a different phenotype. So therefore this has two phenotypes. 1, 2. Go on to the next one. So we have big D, right here. So we have 4/4 big D, little d, or 1 big D, little d. So that's just one phenotype. Times the next one. So we have 1/2 big E, and 1/2 big E, little e. Big E and big E, little e, they're the same phenotype because big E is dominant. So therefore the big E phenotype is going to show. So we have only one phenotype in that one. So just multiply. 2 times 2 is 4, times 2 is 8. So times 1 is just 8. So we have 8 phenotypes. So we need to go to the number of genotypes now. So starting off with A again, all we're doing is just counting how many different ones we have. So we have 1, 2, 3. 3 different genotypes. Times our 1, 2, 3 for B. Times 1, 2 for C. Times our 1 for D. Times our 1, 2 for E. 3 times 3 is 9, times 2 is 18, times 1, 18, times 2 is 36. These are your answers. 8 phenotypes, and 36 genotypes. That's it.